All right, and here we are. So you guys had about, what, 40, 45 minutes to work on this, right? Yeah. Class started, well, 35 minutes ago. 35 minutes ago. So let's go over it together. We're talking about changes of state, right? Different types of matter and what we've got to do to go from one state to the next. So let's look. They gave us 6 words in the top. Now, I've talked to you guys about this, but just in case you've forgotten it, what is another word for solidification? Freezing. So if you see either of those, they are interchangeable. All right? So do not get confused by that. So let's look at number 1. What states are number 1 talking about? Or is it number 1 talking about? Well, what states? Turning solid directly into a gas. Does it turn into a vapor or a liquid and then a gas? No, it skips the liquid phase. So what do we call it? Sublimation. That's a hard one. You've probably not seen that word before. Sublimation. That means to go directly from a solid to a liquid. It's really cool. I like it. There's some really fun stuff you can do. Does anyone know something that goes directly from a solid to a gas?
No. Solid.
Dry ice. I actually am going to get some dry ice here soon. Not this coming week because, yes, dry ice can burn you.
Can you eat it?
I've seen people put it in their mouth, but I wouldn't recommend it. You put too much in there, it might burn you. All right? You can actually buy it at Kroger. I'm going to get some not next week because we have EOCs, but the week after we're going to do a lab where we're going to do all of these changes of states in class. All right? I'll even show you sublimation and deposition, and they're really rare. You don't see them in nature very often at all. All right, what about going from a solid to a liquid? Melting. That one's easy, right? Hopefully no one's going to miss that one. What about number 3? Going from a liquid to a gas? Evaporation. Some people put boiling. So let me show you something. Evaporation. I always want to put evaporization because of vaporization. And that brings us to something that really confuses people sometimes. What do we call going from a liquid to a gas? It's not technically evaporation. It's vaporization. So vaporization is an umbrella term. Now, does anyone know what umbrella term means? I'll give you one. So if I say an automobile, do you know what type I'm talking about? No. But you know what an automobile is, right? So you could have a car, you could have a truck or a motorcycle or a four-wheeler, dune buggy, scooter, right? You have anything. All of those are automobiles. So that's an umbrella term. Vaporization is our umbrella term. There are going to be types of vaporization that we're going to learn about. Vaporization. So who thinks they can give me one type of vaporization? Going from liquid to a gas. Boiling. There's one. Boiling. Now, can you all tell me where, either on the surface or inside the liquid, boiling happens? It happens inside. You ever watch a pot boil? The bubbles come from inside the liquid? Mr. Ray? All right, I'll send her. Thank you. All right, Melina, here's what I'm going to hand out later. Please grab it right there and then walk around. That way I don't have to get you on the camera. Not that I don't want you on the camera, but I got to have Mom and Dad's permission to post it if that happens. All right, so boiling happens inside the liquid.
You forgot the paper.
Right there. Right there. Don't forget that. So boiling is a form of vaporization that happens where, Kaylin? Exactly. Vaporization happens inside with boiling. Vaporization happens on the surface with which type? It's the only one we haven't talked about. Going from a liquid to a gas. It's the one that's on your sheet. Evaporation. There we go. Evaporation. And that happens at the surface of a liquid. Which is why if I fill my coffee mug up with water and I leave it, I will lose some water, right? It'll evaporate. But if I take the same amount of water and I pour it on the floor, it'll be gone quicker because there's more surface area. And that's where evaporation takes place. So what is our next one? Number 4, going from a liquid to a solid.
The S word.
2 words I'll take.
Solid.
Solidification. It's a weird word. I am going to tell you freezing. And that does not mean below 32 degrees Fahrenheit or 0 Celsius. That means the act of going from a liquid to a solid. Freezing.
But that's not in the word range.
I know. I'll take both of them. They both work. All right. Next up, going from a gas to a liquid. Condensation. That one actually has a double meaning. It can either be the liquid that's on the outside of like a really cold glass of Coke or tea or something, or it can be the act of turning from a gas into a liquid. That's condensation.
The D word.
Next up, the D word, deposition. That's going to be one a lot of people forget because you're not used to that word. But deposition is going directly from a gas straight to a solid. It doesn't go to a liquid and then a solid. It goes straight to being solid. You don't see that very often. I only know of one thing I can do, and I'm going to show it to you guys, not next week, the week after. We'll get to see it. Okay. So this information is pretty much the same thing we just saw, but now we're also going to include whether or not energy is added to the material to make it change, or whether energy is released from the material to make it change. And remember, higher states like plasma, gas, liquid, solid, higher states have more energy. So if we're going to go to a lower state, that energy has to be released so that we can drop down. If we're going to go up in energy states into higher states of matter, you got to add energy to it. Just like if you're going to melt ice, you got to do what to it? Got to heat it up, right? Same thing can happen. Just like this, if I heat this brass up enough, it'll turn into a liquid. It can. Yeah. You never seen liquid metal? Bright red, hot, looks like magma coming out of a volcano. It's pretty cool. I've been to a smelting plant where they make steel, and they've got this huge furnace, and they heat up the metal, and it pours out of this giant crucible. It's pretty interesting stuff. All right. Condensation. We're going to go from what to what? Gas to liquid. Ooh, gotta remember to hit that button. Gas directly to liquid. Just like that. And we're doing what with the energy?
Release.
It's going to get released out of that liquid.
Gas to solid.
Deposition is a gas to a solid.
And it's been released.
And it's also going to be released because we're going down, right? We're going from a gas to a solid. So we're going to release energy.
And then you add. And then
Evaporation?
You add liquid to gas. So you add it.
Yep, we're going up, right? So we got to add more energy to it. Added for evaporation. What about melting?
Solid to liquid.
Solid to liquid. There we go. Just like the metal or ice. Solid to liquid. All right, we got to add energy to make that happen.
Liquid to solid.
In solidification, we also call it what?
Liquid to solid. Freezing.
Freezing. And it is a liquid to a solid.
And it's been released.
And we're going from a higher state to a lower state, so we got to get rid of that energy. And I got to learn how to write. There we go. Release.
Solid to
Next
gas.
up, one of my favorites because it's dry ice.
Solid to gas.
Going from a solid to a gas.
And it's been added.
And energy is added. Now the interesting thing with dry ice is I don't actually have to add energy. It's that the air around that dry ice has more energy and it pulls it out of, or pushes it into the dry ice, which allows it to fog up and make some really cool tricks. We're going to get to see. Pretty excited. Okay. Now, you can use these multiple times. A lot of people had trouble with this. So if you tried to, do process of elimination, it didn't work, did it? What about ice being left on the counter? What's it going to do?
Milk.
It's going to melt, right? So that is letter E. What about frost forming on the window? This one.
B or F.
Exactly. Perfect. So before it can become a liquid and freeze, it has to condense. That warm air touches that cold windshield and goes from a gas to a liquid. Then, if it gets cold enough, that liquid turns into a solid piece of ice. That's freezing. So I'll take either of those. And they're still calling it solidification.
That's next, the F word.
Next up, water is left in the freezer. It's going to
F.
freeze. Solidification or freezing. What about, popular today, Mr. Ray?
Hello? And Mr. Ray.
Okay, I'll send her. Thank you. Denaria, you a free woman. I'll have this video up on Blackboard. Grab you one of these on the way out, okay?
I already got it.
You got one? All right, awesome. You have a great weekend, ma'am. All right, if clothes are left out, what are they going to do? They're going to dry. But why? They're evaporating, right? The water is leaving the clothes and going out into the air, right? So that is evaporation. That's C. What about dry ice making fog? A, sublimation. Exactly. What about the bathroom mirror getting fogged up? B, that's correct. Condensation. All right. I have actually got a special mirror in my bathroom that you can put water behind. It's like got a container behind it. So it makes the mirror the same temperature as the water so it doesn't fog up. It's really cool. I use it to shave. Exciting stuff. Huh? Yeah, kind of. Yeah, I kind of use science. I saw it at the store, and it relates directly to what we're talking about. Now, some of you guys are probably already shaving. You'll understand. You go and try to shave after you shower, you can't see anything. All right. Next up. I'll wait. Waiting. About 2 people. Come on, guys. We're almost done. All right. A pond gets shallower. That means it's going to get lower level. Where's that water going? It's going to evaporate. Exactly. What about if you're lucky enough to have hair? If you leave the house with it wet, it dries by the time you get to school. C. Evaporation again. Looks like evaporation is pretty popular, right? What about ice cream? E. It is melting, which is sad because I love ice cream. And I hate it when it melts faster than I can eat it. What about a full pot of soup? C. Evaporation. You really think evaporation? I think this is technically an incorrect word. What should it have been? Boiling. Now, they didn't give you boiling as an option, so evaporation is the best answer. But it should have been boiling, right? Because you're actually simmering it. That says summering, but it should be simmering. It's a low boil. What about liquid glass cooling and hardening? F, solidification or freezing. Now, do you guys think that glass is a solid?
Yes.
Yeah, it feels pretty solid, doesn't it?
Yes, but it's liquid.
Well, it's actually a semi-solid. Glass actually changes shape over a very long period of time. Anybody ever been in a really old house and noticed that the windows look kind of wavy? Like when you look through it, the windows look kind of funky? Yeah. What happens is on old glass, if you let them sit in that window frame long enough, the base will end up thicker than the top is. That's because those atoms in that glass are moving really, really slow. Kind of like how you can't really see a plant grow, but you know it's growing. Same thing's going on with that glass. Those atoms are slowly getting pulled down by gravity. Now, we've got new glass that doesn't do that, but used to that happened. Next up. Cold drink is wet on the outside of the glass. Why? E. Melting? It is B. Condensation. Can somebody describe what's going on with that glass? We've all seen this, but why is it happening? Well, there's no frost on it. Like I can take a warm soda, set it in my freezer or fridge, get it nice and cold, and set it outside on a hot day, and then the glass will start to sweat. Why do you think?
Because they're humans.
No. So right now, you can't see it, but there's water vapor in the air right now. We're breathing in small amounts of water. Can't feel it, you don't know it's there, but it's there, right? So what happens is that warm water vapor touches that really cold can. And when it touches that cold can, it pulls the energy out of the vapor and condenses it, and it sticks to the side of the can. So that is why your glass sweats. It doesn't come from inside and go out. It actually comes from the outside and sticks on the outside of the can. All right? Next up, these are the hard ones. These you got to kind of come up with your own answer. How do we cause matter to change from one state to the next? What do we have to do?
By using heat.
Well, what do we do with the heat? We add or release energy to cause those states of change, those phase changes. So if we want to go from a solid to a liquid, what do we have to do? Add energy. If we're going to go from like a gas to a liquid, what do we got to do? We got to pull energy out of that material. Huh? Where's my pass? Here. There you go, buddy. Okay. So we have to add or release energy. Or release energy. Just like that. Now, this is the hardest question on this assignment. What is the relationship between the amount of space between the particles and the state of matter? So imagine looking at the particles for a solid, liquid, gas, and plasma. What are the particles going to be like, Landon? Solids are going to be really tightly packed. What about liquids?
They're a little looser.
They're still kind of connected, but they're not connected very well, right? Kind of like they're elastic. What about gases? They're moving all over the place. And then plasma is an ionized gas. So not only are the atoms moving around, but there's so much energy in it that the electrons break free of the atoms and they're allowed to float around. That's why plasma conducts electricity. Okay, so what's it like the fourth? Mr. Ray. All right, I'll send him. Thank you. Landon, do you have a copy of the vocab practice? Yeah. No, it's right there. Grab you a copy on your way out, man. You have a great weekend, okay? So does everyone know number 11? You got an idea of what you need to put?
Yep.
Atoms are not spaced out in a solid. They're kind of spaced out in a liquid. They're really spaced out in a gas. And then in a plasma, everything is spaced out. Even the electrons and the atoms. All right? What about number 12? Number 12 says, how is melting similar to freezing and how is it different? Let's start with the differences first, because I think differences are easier to notice. Melting turns a solid into a liquid. Freezing turns a liquid into a solid. That's an obvious one. How else are they different? Exactly. One of them you have to add heat to cause a phase change, and the other one you have to release heat to make a phase change. Right? What about similarities? How are they similar? This is a little harder. Because they're opposites, right?
They both change the state.
They're both a change of state. Exactly. There's one thing. Now, this is a tricky one. I actually had a student get this one without me telling them. I was really impressed. There is a name. Hold on. Sorry, viewers. Come on in, bud. While we're waiting, the lovely periodic table of elements. Ooh, We are experiencing technical difficulties. I hope somebody watches this and laughs. That's all I got to say. You're going to be in your house at like 10 o'clock at night watching Mr. Ray's lesson and be like, man, Mr. Ray's crazy. He's nuts. You're going to have nightmares. Hopefully my lessons don't give you nightmares. All right. So another similarity is they both require the same amount of energy to change. The amount of energy to go from a solid to a liquid is the same amount of energy that's released to go from a liquid to a solid. Does anyone remember what we call that amount of energy? The heat of fusion. Heat of fusion. Because you fuse atoms together to make a solid. That's how I remember. Fuse together to make a solid. Or fuse for freezing. Watch those F's. Right? Everybody got a pretty good idea of what that is? Good Lord. I am popular today. Okay. So that is all of this. What we're going to do now is I'm going to give you guys your vocab practice. You've done your vocab sheet, but you haven't had an opportunity to practice with your vocab words yet. So I've got a crossword puzzle for you. There are 20 vocab words. There is a slight issue with the formatting. Number 10, 18, 12, I think that's it. They're in there, but they're kind of in a weird spot. They're not lined up perfectly. All right? They're there. So I'm going to give you guys, y'all have about 23 minutes. That should be plenty of time. If we have time, we'll go over it together, okay? Yes. Yes. Thank you very much, guys. Y'all did great.